Welcome to the next episode on Learn Plus AI series, where we are learning to build a AI resume refiner. In the last video, we saw that we were able to add authentication into our system. The user would come in, they would enter the login name, username, and email and password. The system will validate it, authenticate it. But let me ask you something fundamental. Is that interaction during login, is it like permanent relationship with the server, or is it just one time interaction with the system? Here is the uncomfortable truth about the web. The server does not remember you. It is not a bug. Every request from the client side is independent of the previous request. No memory, no context, no history of the previous interaction. And this is not a bug again. This is by design. So for example, you came to the system, you entered your login username and password. You are authenticated. But then let's say you're trying to access a resource, let's say your resume in our case. It might be the case that your server will say 401 unauthorized because this new request to the server to get your resume has no prior information whether you were authenticated or not. This behavior has a name. It is called stateless communication. Every request from the client side to the server is independent, which means that the request itself does not carry any information from the previous interaction. Now comes the most important question. Why statelessness exists? What is the need of this? It was chosen by design, not because developers or engineers forgot to add memory or did not consider memory, but the idea was to make the server more scalable. Now imagine millions of users sending requests at the same time. At the same time, there are multiple server systems enabling that service. Now, which server should remember which user, right? And if, let's say, that server which remembers a user crashes or is replaced or is busy, the entire system crashes. Think of a food delivery company, for example. Like if the food delivery guy, if there was just one single food delivery guy delivering your food every time, and if they had to remember your name, your address, your preferred mode of payment, let's say, right, this system would not scale, right? So instead, what happens is every time a new person might arrive at your doorstep, they don't remember anything of your previous interaction with that company. They have a slip, they just read it out. That is how it works. That is how it scales. That's exactly why the web chose statelessness. Any new server can be added, any existing server can be removed, and failure with any one server does not bring the system down. Later architectural styles like REST embraced and formalized this idea. But the problem, the main challenge that now comes to our system is we don't think in terms of request. Think in terms of sessions. I logged into the system. I'm authenticated. Now I expect that I should be allowed to access any resource in the system for which I have the access, right? I expect continuity. This is a different problem. Bcrypt in the last video that solved the problem of authentication. Now comes the problem of continuity once we are authenticated. So now the problem with the system at hand, which we are building is how do I remember the user once they are logged in so they can access so that we can serve to their request without asking them for the password every time again and again on every fresh request which they send. Let's talk about real world example so that this idea of authorization it's a lot more clear and intuitive. Imagine going to a concert and you show your ticket at the entry gate and they verify the ticket and they put a wristband. They put a color coded wristband. Now once the wristband is on your wrist, you can now roam freely in the entire concert zone. You can go inside and out. You can go to different areas in the concert. That band itself tells all the guard that you have been authenticated and you are a legit attendee of the concert. Your color code might determine your seating area. It might determine which zones you're allowed to go or not. Nobody talks to another guard. Every guard sees the color band. They don't ask your name again. They understand that you are now part of this concert, right? That is what we want to build now. So we need a similar bridge in our web world, something that the users can carry, something that server can verify, something that is lightweight, temporary, and safe, reliable. That something is called as token. And in today's video, we're going to learn about token based authorization. Now, so far, everything makes sense that the server needs to be stateless, the user should carry a token, and that token represents prior authentication. But there's one more question that we need to ask. How does the server trust the token it did not store? How does a server verify that the token was not tampered, forged, modified, or maybe reused incorrectly? Let's go back to the concert. The guards can look at the wristband and can tell you that you are a valid attendee of the concert. Why? Because they have understood that what particular material the wristband is, what embeddings are there, what event specific design is present on your wristband. They can ensure that yes, this is the right band for the today's concert. That's how the server also remembers our that's how the server also validates the token. It does not remember anything. It adds a special content called as a signature to the token, which is created at the time of the token creation itself. And the next time when the token arrives, it kind of verifies that signature. You could think of those series like Game of Thrones series if you have watched, where one particular house wants to pass a sensitive information to the other house. What they do is they pass a content in the envelope, they pour some wax and they have their own seal, right? Then when the letter arrives at the different house, they can look at that seal. If the seal is intact, if the seal belongs to the right person, they know that this was not tampered with. How is the signature created in the system? Signature is created with the token's content and then with a secret passphrase that is maintained at the server side. Both of these are kind of used to create a very unique signature. Now, if any user tries to modify or tamper with the content, what happens is the signature will no longer match. So if the tampered token arrives at the server side, they will create a new signature from the content and they'll try to match it with the existing signature. And based on whether the signatures are matching or not, server will know whether the token is correct or has been tampered with. So to summarize, the trust factor with the token is built using cryptographic signature, your time limits, and the server maintained secrets. Now that we understand a little bit more about the tokens, let us understand the journey the JSON Web Token goes through. This understanding is very important. Later we'll start to do some hands-on coding to understand how to create and work with tokens. So step number one, what happens when a user wants to access a system? They enter their login credentials, they enter their email and password, server authenticates the user and then creates a token. The token contains who the user is, what roles or accesses they have, and how long this token is valid, the expiry time for the token. So step one, user logged into the system. Step number two, the server created the token. Step number three, the token is sent back as part of the response and the login request. So once the login is completed, the token is sent as part of the server response and it is received at the client side. This is just the moment that your ticket has been verified at the concert and the wristband is now placed on your wrist. The fourth step now is that the token needs to be stored on the client side. It can be in your cookies, it can be in your local storage, some memory apps, right? And depends upon how you're trying to configure and work with the system, right? And we'll see a more secure way of doing this in our application. But the important part here is that the server does not store that token. It is sent to the client who stores it. Step number five. Now, every subsequent request that you make after the login, the token is sent along with that request, usually in the request headers. Right? This is just like you got the wristband, now you're walking in and around the concert area. Step number six. Now, when the next request goes to the server will look at the token that comes with the request. It will validate the signature, the expiry time, the roles or the accesses that is assigned. And if everything looks okay, the request will be allowed to continue. The requested resource will be served. Otherwise, your request will not be allowed to proceed further. you will get a 401 unauthorized error. And we'll build that capability. Now that we understand the journey, we are ready to look inside the JSON web token. The creation, the verification, all of that itself is not too much of a code. It's a little bit of understanding that we need to develop before we start see the code in action. Let's do that now. Now, JWT is not magic. It is a carefully designed envelope. On the surface, it looks like one giant big string. And if you look at it closely, it is actually three small strings separated by a dot. If you notice a dot over here, string number one, then a dot, string number two, then again a dot, and then string number three. This entire till the end. Let's now decode these parts individually. The first part is the corresponds to the header. What is the header? What type of algorithm should be used while creating the signature? And what kind of token is this? So this is a JWT JSON web token. There are JSON JWE encrypted form of tokens. So there are different kinds of tokens. So this header data tells us about the algorithm used and the type of token. The second part of the JWT, which corresponds to the payload, this is a more important part from our perspective. This contains information like the subject, any other details you want to pass along with the token, like the name, the admin, the roles basically, and the time of creation of the token. All right. Now, if you can see that these payloads, these are encoded, right? These are not encrypted. So we should not be passing sensitive information like passwords and all of that and as part of the token itself, because it can be decoded and the payload can be read. The last, which is important from the server side, is the signature itself. So what it happens is at the time of token creation, your header data is mixed with the payload data along with a server side secret which is maintained. Now here it is short for the reference point of view, but this will be stored secretly and very it will not be visible basically to the generally we store this in the environment file, or the time of deployment will store this as a configuration variable. So basically your header data is mixed with the payload and the environment secret, and then a signature is created which becomes the part of the token. Now if any character is tampered with, what happens? The signature itself changes, right? So that is how your server is able to validate if the token is legit or not. So till now, everything was mostly theoretical, but important theory from the concept point of view. Now let us go back to the project that we have been building and try to add JWT. We'll not be doing the authorization part completely in this video. We'll just see how the token is created and how it is read and how it is returned from the server. So let's go back and now fix our login route. Now we are in the login route, and what we see here is we are getting the email and password from the request body which user has sent. We are trying to get the user. If the user does not exist for that email, we are simply saying that it is invalid credential. If the email is correct, we're now trying to compare the user entered password with the password stored in the database. If it is a mismatch, we say invalid credential. Otherwise, we're returning login successful. Now, this is the part where we want to create the token, right? So what we're going to use is will use JSON web token as the package. So we'll install the JSON web token package npm i JSON web token. This will install the package node package which we need, and by the time it gets installed or it is already done, we'll import the JWT also in our project. Import, give it a shorter name from the package JSON web token. Now we come back to the login part. Now here is where we create the payload. The payload means the content which we want to pass into the token itself. Will not pass a lot of information because as we had seen that can be decoded. Will pass just enough that the server would need. Let's say a user ID which will be user underscore ID. This underscore ID is what we get from the MongoDB, right? The unique identifier. Let's say we also pass the email. From the user ID itself, we can figure out other details, but let's say for Just for this purpose, we are sending ID and email. Now, what we want to do is we want to sign the token. We want to create the token and sign this. So, what we do is we say const token, the JWT package which we imported, called upon the sign method. If it takes the payload, secret key, right, and then some other additional options, the expiry, etc. So, what we'll do is first we'll pass the payload, then we need a secret key. So, secret key, what we'll do is we'll create it in the environment file. Something like JWT secret, super secret. You can give any passphrase. Just let me copy this key. And we'll say process.env dot the same label which you are given in the environment file. The last bit is the expiry. So what we'll do is this will take the expires. This takes an optional object, sorry, and we can pass an expires in property. And then we can say whether it is 15 minutes or 1 day or 7 days, 1 week. You can accordingly mention it like this. DMY, these are all valid suffix. So for now, we are keeping expires in 15 minutes. Now, this is all you need to create your token. The payload, environment secret, and a time to basically which tells the expiry of the token. Now, what we want to do is instead of just returning our message, we'll also return our token. And that is it. Just notice, look at this statement again carefully. We created the token. We did not store it anywhere in the MongoDB or anywhere in our system. We're just returning this token back to the user. We're just placing the wristband on the wrist of the user. Now let's come to the postman again and test our endpoint. So we are hitting our login route. We have the server running. The email and the password is placed. Hit the send button and we see the login successful and the token also. Let's copy this. Let's copy the token. Let's head over to the JWT IO. Let's replace this with the token that we have copied and notice the user ID, the email which is corresponding to the email that we have sent. This user ID will be matching to our MongoDB. We'll show this. You'll see this shortly. This is the token creation time and this is the expiry time, 15 minutes after the creation. So we are inside the MongoDB for our database, for our document. This is our user node@gmail.com. Notice the user ID 694 and ends with 072. This is the same user ID 694 ending with 072. So what we have seen now is, my dear friend, is that we are able to, when we log into the system, we are able to create the token and send that token back along with expiry, along with the payload that we want to be sent as part of the JWT token. In the next video, we'll build the guard. So now we have built the wristband, which identifies, which authorizes you in the concert. Now we'll place our guards because without the guards, there's no point in basically creating those wristbands. There should be a system to validate these tokens, and which is what we'll build in the next video where we learn about middlewares and then we'll create some authentication middlewares. But just before we wrap up, one important communication. Token-based authorization are not the only way to build secure systems. Many systems, traditional systems still uses server-side sessions. Some API uses key-based authorizations. Some system use certificates for creating those authorization system. In our case, we are building a single page application and token-based authorization fits really well, which is what we'll be doing. So in next video, come back and where we learn how to create middlewares and how to use and validate the legitimacy of our tokens. Thank you. Have a very good day.